We're on the Chapter 5 review, question number 7. You're supposed to be taking notes, so be sure you take notes. We're talking about parameter changes here on number 7, 8, and 9. Parameter changes involving parallel and perpendicular lines. There's some rules about parallel and perpendicular lines that we learned on page 132 of the text that you need to have memorized, and then the lesson itself was on page 135 to 136. On page 132 it says parallel lines have equal slopes and never intersect. Perpendicular lines have inverse reciprocal slopes, meaning flip it and change the sign. So perpendicular lines have inverse reciprocal slopes, meaning flip it and change the sign, and they intersect at 90 degrees. And then we have the horizontal vertical stuff that we have to remember. A horizontal line is a y only. It has a slope of 0, and the y-intercept is the constant y value. An x-only equation is a vertical line. It has a slope that is undefined, y-intercept none. So when we get to the x-only, y-only, then we don't think inverse reciprocal slopes. They have memorized slope values, right? So you got to remember that stuff. Okay, here we go. What we did in the page 135, 136 is we wrote old and new. We kind of ran an old new drill, and that kind of helped us be organized and successful. So we're going to do it the same way. Old y-intercept, old slope, new y-intercept, new slope. We're going to use our new y-intercept and our new slope to write our new equation, which is what we're trying to accomplish. Whoops. It says write the equation in slope-intercept form of a line that is perpendicular to y equal 3/4 x plus 5. Now, first of all, what is the y-intercept of this original? The 5. So the y-intercept of the old equation is that 5. The slope of the old equation is 3/4. And has a y-intercept of 2. So my new line has a y-intercept of 2. So my new y-intercept 2. We need to find the new slope. It says that the lines are perpendicular. Perpendicular lines have inverse reciprocal slopes, which means that you flip it and change the sign. So my new slope is -4/3. Everybody say we found the new slope and the new y-intercept. So I can write my new equation. My new equation will be y equal slope -4/3 x plus y-intercept 2. Any questions on number 7? Parameter changes involving parallel and perpendicular lines. They got that? Number 8, write the equation in slope-intercept form of a line that is parallel to 5x plus 3y equal 12. Now, what we want to do is we want to name the slope and the y-intercept of the old one. And use those with the information given to find the y-intercept and slope of the new one. Then use my new slope and new y-intercept to write my new equation, which is what I really want. What is the y-intercept of the old one according to that yellow equation there? We don't know, because that yellow equation is in standard form, and you cannot identify the slope and the y-intercept until you put it in slope-intercept form. So my first job is to take this equation, 5x plus 3y. I'm going to do this somewhere else because that's not working very good right there. I'll just do it up here. So we're going to take the 5x plus 3y is equal to 12. We're going to go from standard to slope-intercept, which means we need to isolate the y. To isolate the y, my first move is to move the x to the other side, remembering to change the sign when you cross over. And so we get 3y is equal to negative 5x plus 12. If you want it in y equal mx plus b form, you want the x stuff before the b stuff, right? And now we're going to undo multiplication by division. When you multiply something to or divide something by a sum or difference, you have to put that sum or difference in parentheses and distribute. So we're going to distribute that divided by 3, and we get y is equal to negative 5 divided 3, which we leave as an improper fraction, negative 5/3 x. And then the 12 divided by 3 is 4. So we have gone from standard form to slope-intercept form. The old slope is, the old y-intercept is 4. The old slope is negative 5/3. Yes. It says it passes through the point 0, 4. That's the value of y when x equals 0, which is the definition of y-intercept. So that's the y-intercept of my new one, the value of y when x equals 0. It says that they are parallel. Parallel lines have equal slopes. My original slope was negative 5/3, so my new slope is the same, negative 5/3. Parallel lines have equal slopes and never intersect. Understand number 8 so far? So we have found our new slope, we found our new y-intercept, so our new equation is y equals slope, negative 5/3 x, plus the y-intercept, plus negative 4, but we don't write it as plus a negative 4. We write it as minus 4. Any questions on 7 and 8? That's the y-intercept. Telling you the y-intercept. So there's two ways I've told you the y-intercept. On the first one, I said the y-intercept, it has a y-intercept of negative 2, of positive 2. On the second one, I said it passes through the point 0, negative 4. That's y when x is 0. So there's two ways we've given you y-intercept. Sometimes it'll say the new y-intercept is 6 more than the old one. So there's a third way you could get the y-intercept. Have to add or subtract something from the old one. Any questions on that? Okay. Number 9. Number 9, it says the equation of the line that is perpendicular to x is equal to 3 and passes through the point 3, 7. Now we're talking about perpendicular to x equal 3. First of all, what kind of a line is an x equal 3? It's a vertical. What is the y-intercept of a vertical line? It doesn't have one. None. What is the slope of all vertical lines? Undefined. So my old equation is a vertical line with an undefined slope and no y-intercept. It says perpendicular. What kind of a line is perpendicular to a vertical? A horizontal. And so my new line is a horizontal line. What is the y-intercept of all horizontal lines? The constant y value. The equation of a horizontal line is y equal the constant y. The y-intercept is that constant y. The slope of all horizontal lines is 0. We need to find out what that constant y is so that we can write our equation, right? We're not really using our y-intercepts and slopes here to find our new equation, right? We could have left that whole drill out. Now, we know that if it's perpendicular to a vertical, it's a horizontal. And if it's a horizontal, it's y equal the constant y. But what is that constant y? It says it passes through the point 3, 7. That means that this horizontal line contains one point that we know of, and that one point we know has a y of 7. And so a horizontal is y equal the what? Constant y. So y is constantly 7. If one point on that horizontal line has a y of 7, then that's what they all have because it's a constant y value. So my answer, y equals 7. Any questions on number 9? So 7 through 9 were parameter changes involving parallel and perpendicular lines from page 135 to 136 of the text. Yes, ma'am. So the y-intercept would be that constant y7. Thanks. Yes. Yes, sir.
So is there going to be a number 6
Oh, did I leave? Oh, no. We will, on the test, we will omit matrices question on the test. Correct. All right, any other questions here? All right, number 10. Number 10, it says, Kim went to the concession stand and bought drinks for 75 cents each and hamburgers for $1.50 for herself and her hungry cousins. Each person got one drink. Some cousins got more than one. If Kim bought 20 items for $24, then how many cousins were with Kim? Now, I need to tell you, first of all, that when I say how many cousins are with Kim, then I wasn't including Kim. Now, she's one of the persons that got something to eat and drink, so I was kind of trying to be sneaky and say whatever you got. For a number of people, you have to take one off, but anyway, either way it's acceptable. On the test, I won't make it tricky like that, maybe. Anyway, there's one in here that knows the answer to that without even working this problem. But here we go. We're going to read and understand the story, right? Identify the character or characters of the story and assign variables. So we're going to write characters. And we find our characters from word sentences, and there may be 1, 2, 3, 4, 5, depending on the number of characters. Word sentences, we're quoting page 40, could be a comparison between two characters, like Joey ate 6 times as many hamburgers as Kelly or something like that. Or Rance drank twice as many Cokes as Chance or something like that. So that's the kind of thing that could be a comparison between two characters. B is formula words like perimeter, area, volume, circumference, and all the stuff from chapter 3, 4, 5, 6 that we're adding into those formula words. And then C is sentences containing words like total, sum, difference, product. And we've learned that Sometimes it doesn't say the word total, but it's an understood total. And we learn things like total amount, total value in our Chapter 5 word problems on page 151 and 2 and down in there. Okay? All right. So we go in search of word sentences. Kim went to the concession stand and bought drinks for 75 cents each. What's that? That is the dollars per drink. That's drinks slope. That's what it is. It's value per drink. It's not a word sentence. It's slope for drinks. Okay? And then it says hamburgers for $1.50 each. What's that? That's hamburger slope. Dollars per hamburger. That's hamburger slope. It's not a word sentence, but it's a value statement. The value statements are MX's, right? Or they're M's. All right, for herself and her hungry cousin, so that didn't do us any good. Each person got one drink. Now that helps us, that basically says that the number of people is equal to the number of drinks, right? P equal D. The number of people is equal to the number of drinks. That's going to be important to us in just a moment. Some cousins got more than one burger. If they didn't, you'd know how many, because there's so many burgers, you know. Anyway, some of them old boys ate more than one. If Kim bought 20 items for $24, what's that? Total amount of items and the total value of those items. And so we have a total amount and a total value that we want to make right. So those are our word sentences, right? Total amount, 20. Total value, what's our value measured in? Dollars. What other things has our value been measured in this course? Gallons of pure alcohol, pounds of pure protein, and amount of money, right? Those three things we've dealt with. Total value, $24. We need some characters. What do we need to know? What is my total amount? Total amount of what? Items. What types of items? Ingredients. Hamburgers. So number of hamburgers. We'll call H. Number of, what's the other ingredient? Drinks. Which we'll call D. And we really want to know how many cousins were with Kim, which is going to be one less than the number of drinks, right? Because we're not going to include Kim, but we'll mess with that later. Now this is items. Items, right? The total amount of items. What's my equation for that? H plus D equals 20. The number of hamburgers plus the number of drinks is equal to 20. Items plus items is items. And then we need value. How do we go from the variable given H into dollars? How do we go from H to dollars? You take dollars per H times H. If you want to go from H to dollars, you have to cancel out your H. You have to lose the name H and gain the name dollars. So you take dollars per hour times number of hours. That's an MX, or a dimensional analysis situation. What is the dollars per hour, dollars per hot dog? What's the dollars per hamburger? What's the dollars per hamburger? 150. So 150 per hamburger H. Dollars per hamburger times number of hamburgers gives us value in dollars. So that 1.50H doesn't stand for H. It stands for dollars, right? The H is going to get kicked out of the story, right? It's all about why. Anyway, so how do we get drinks? How do we end up with dollars if we have drinks? You take the dollars per drink times the number of drinks, and it cancels out your drinks, and you turn drinks into dollars through dimensional analysis. So we're going to have plus the dollars per drink, which is 0.75, times the number of drinks, D. 0.75 D kicks D out of the story, and you end up with dollars. And so we have dollars plus dollars is $24. Any questions on how to set up these total amount, total value word problems, and how we actually are using dimensional analysis to do that? Okay? All right, we have a system of two equations with two unknowns. We want to solve by either graphing, which isn't very accurate, so we never choose that one, or substitution or linear combination. Substitution because we have one that's pretty clean, right? So we want to isolate one of our variables like D. But let's think about this. Do we want to end up with D's or H's? D's. We want to know how many cousins were with Kim, and the number of cousins is equal to the number of drinks minus 1, because we're not going to count Kim. Okay? That means we need to solve for the number of drinks. So do we need to get rid of our H's or our D's? We need to get rid of our H's. So we need to isolate the H. You knew that. You're going to subtract D so as to isolate the H. Then you just have to plug it back in, and you'll get there. Just take you longer. So it says H is equal to this D stuff. We're going to replace H with that D stuff and get a D-only equation. Again, if you did that backwards, you just have to plug in at the end. It's not going to make a big deal in the long run. We have 1.50 times H. We have times a sum or difference. So we put that sum or difference in parenthesis and distribute. Everybody see how we got to that point? So now we're down to a D-only equation, so we now solve using the order of operations. It says to do anything you can to simplify the order. Please excuse my dear Aunt Sally, looking for distributive property and combining like terms. So we distribute. 150 times 20 is 30. 150 times negative D is negative 1.50 D plus 0.75 D is equal to 24. But see how we did that step. We're still on part 1 of order of operations horseshoe. Is there anything I can do to simplify? Looking for distributive property and combining like terms. Now y'all have learned to be careful there, because you have to really watch your sign rule stuff, right? You can really mess up. What's the sign of the 150? Negative. What's the sign of the 0.75? Positive. When you add or subtract with different signs, you subtract and take the larger. 150 minus 0.75 is 0.75 D. The larger was negative, and so we need a minus in front. And so we have 30 minus 0.75 D equal 24. Everybody see what we got there? We good? Okay. So, is there anything else we can do to simplify the left? Nope. Is the variable D that I'm trying to isolate on both sides? Nope. That's the bottom of the horseshoe, right? And now it's time to undo. We're going to undo addition by subtraction. And so we subtract 30. We get negative 0.75 D is equal to negative 6. When you add or subtract with different signs, subtract and take the larger sign. So now we're going to undo multiplication by division. We divide by negative 0.75. Divide negative 0.75. And we get that the number of drinks is 8. So there's 8 total cousins. There's 8 total drinks. There was 1 person per drink. That means there was 8 people. If you want to know how many cousins were with Kim, not including Kim, she had 7 of her cousins with her. If you include her, then you would have put 8. Any questions on that? That's the cousin club. That counted her sisters, actually, yes. I don't know. We'll see. We'll look at it later. Any questions on number 10? So actually, there's 8 total cousins, sisters, and Kim. Any questions there? All right, number 11. Now, I wrote number 11 exactly the way we do it with our show animals, okay? Yes. 8 drinks, 8 people, 7 in addition to Kim. She made 8. Number 11, Joey has a show lamb and he feeds it 4% of its body weight in feed a day. This is what we do with our show lambs for the county show here, okay? Joey's lamb now weighs 112 pounds. That's what it weighed when I wrote this problem. Joey has been feeding it DQ45, which they don't make anymore. The plant burned down, but anyway, that's what I used to feed. It's an 18% protein feed. He wants to boost the protein level up to 30% 2 weeks before the show to bulge its muscles. We're just going to add a little protein, just run it, cut the fat, firm it up, right there we go. How many pounds each of the 46% protein fish meal and 18% DQ45 should Joey mix together each day to reach his goal? Now you can feed fish meal, or you can feed soybean meal, or you can feed cottonseed meal. Fish meal is pretty high in protein, but I found that you don't want to try to eat the lamb afterwards because it tastes like fish. So I don't recommend feeding fish meal to a market animal. Nobody's going to want to eat it when you get through. So you really should feed cottonseed meal or soybean meal. Anyway, we're going to go ahead with this one like it is and hope that you don't have to eat this one. Anyway, tastes a little fishy. So here we go. We're going to write characters of the story. And we're going to be in search of word sentences. Joey has a show lamb and he feeds it 4% of its body weight in feed per day. Joey's lamb weighs 112 pounds. Now what am I going to do with that information? What's that information going to give me when I put those two things together? It's how much he's going to feed it. My total amount of feed that I'm going to feed that lamb is 4% of its body weight, 112. I'm putting those two things together to come up with my total amount equation. The total amount of feed, DQ45, and fish meal included, is going to be 4% of his body weight. To change a percent to a decimal, you move it 2 places, 0.04 times his body weight of 112 pounds. That's the total amount of feed that we're going to feed that lamb. 4% of his body weight in feed per day. What I need to know is how many pounds of that is going to be DQ45 and how many pounds of that is going to be fish meal. I'll just call DQ45D and fish meal F. Now, my first equation is total amount of feed. Pounds of DQ45D plus pounds of fish meal F needs to come out to be my total pounds. What's for 4% of 112? 4.48, right? So we're going to feed that lamb 4.48 pounds of feed a day. The pounds of DQ45D plus the pounds of fish meal F need to add up to 4.48. Buddy, with us there? Now, not only do we want to get the pounds of feed right, we want to get the protein content right. That's my total value, right? So I've got to get the total value correct. And my total value is not measured in dollars and cents. It's measured in pure protein. And the way we find pure protein is we take the percent times the whole to get the part that represents pure protein, right? We're dealing with percentages here. Now, what protein level are we trying to get to? 30%. My result needs to be the yellow stuff. I need to get my total amount right, 4% of his body weight. And of that 4% of his body weight, that 4.48 pounds of feed, I need 30% of it to be pure protein. So how much pure protein am I going to need? 30% of that. And so my total pure protein is 30% of that 4.48 pounds of feed. Understand that? Now how much is that? 12, 1, 3, 2, 4, 13, 4. Somebody hit it right quick. I lost it. What's that? 1.344? There you go. So 1.344 pounds out of that total 4.48 pounds is pure protein. The rest is carbohydrates and fat and starch and vitamin E and vitamin D and all that other stuff. Okay? How do we come up with our pure protein? You understand this whole equation's about pure protein? That means we need protein plus protein is protein. That 1.344 pounds is pure protein. Yes, ma'am. This one right here is multiplication. And then that's a decimal. On the other two are decimals. So that's 0.30 and 4.48. Now, how do I get the amount of protein in D pounds of DQ45? It's 18% protein. To find the amount of protein in D pounds of this, I take my percentage as a decimal, 0.18, times the amount of feed D pounds. That gives me pure protein. Looks like an MX, dimensional analysis, doesn't it? We're going to kick out pounds and end up with protein. Because when you take percent protein times whole, you get protein. Part equal percent times whole. Works like dimensional analysis, you see. How do I go from pounds of feed to amount of protein? I take my percent times my whole, and I get my part. The amount of protein in the fish meal is 46%. I change my percent to a decimal and multiply it by the whole amount of feed, and it tells me how much protein is in it, right? Part equal percent times whole. So we have protein, protein, protein. Any questions on how we got that second equation. Part equal percent times whole. Okay? Now we're going to solve, so we need to isolate one variable. It wants to know how many pounds of each, so it's not going to matter which one we solve for, right? So we're going to isolate one of the variables like D. So we're going to subtract F. And so we get D is equal to 4.48 minus F. We're going to take what we got for D, substitute it in place of D, and solve for F. And so we're going to get 0.18 times D. D is a difference, and so we put it in parentheses and distribute. And then we still have the plus 0.46 F is equal to 1.344. That's a 4, I can't, there's no way I'm going to get that to hit in the right spot. Okay? So we're down to an F-only equation by substitution. Now we're going to do whatever we can to solve in the order, please excuse my adherence, remembering to look for distributive property and combine like terms. So somebody help me out here. 0.18 times 4.44. 0.8064. Thank you. 0.8064 minus 0.18 F plus 0.46 F is equal to 1.344. Now, we're going to do anything we can to simplify, looking for distributive property and combining like terms. We combine like terms using sign rules. That's a negative 0.18 F, and it's a positive 0.46 F. When you add or subtract with different signs, you subtract and take the larger signs. We get 0.08064. What do you get on your F's? Plus 0.28 F is equal to 1.344. I can actually get that second 4 in there now. Now we need to undo. We're going to undo addition by subtraction, so we subtract 0.8064 minus 0.8064. If you're doing it on paper, don't forget to line up your decimals. So I'm going to move that way up here. Point what? So 0.28 F is equal to, one more time, 5.5376. Thanks. Now we're going to undo multiplication by division. We divide by 0.28, and we get F is equal to 1.92. That's what I was thinking. That's a little short on fish meal. Lamb would be very happy about that arrangement, and the people that ate him also probably. But anyway, F is equal to 1.92, rounded to the nearest pound of, the nearest hundredth of a pound of sweet feed. Yes, and it tasted like a fish. Not good. Anyway, so we get 4.48 minus 1.92. And so we get the number of pounds of DQ45 is 2.56. Thank you. So 2.56 pounds of the original sweet feed DQ45 and 1.92 pounds of fish meal. That's almost half and half, which would be a very tough flavor. Anyway, everybody said we do that. We use cottonseed meal and soybean meal now to do the same thing. I just use one or the other. Sometimes I use one, sometimes the other. Depends on the year and what's available. Any questions on the Chapter 5 review? All right, we'll put that away, and then we're going to begin another recording here in just a moment.